We're ready to start measuring and constructing segments. Now, reality, this is the name of the lesson in our textbook. We will not actually get to construct segments this year. We're still on a shortened year for construction for the school district. So, therefore, we don't get to do constructions in geometry. But the focus here is going to be that you can find segment lengths using the ruler postulate. And that's really just flat out measuring. And then the other focus is that you can find segment lengths using the segment addition postulate, which is probably a little bit more like algebra. So we'll kind of do the physical world, and then we'll do the manipulation of numbers world as we work through this. So first off, the ruler postulate. And postulates in geometry are things similar to how I talked about we had undefined terms. Well, postulates are things we just have to agree that this is a convention we're going to use. It's not something that I can actually prove, but it does mean that we can actually talk about things. And it's so important for us to be able to talk about things. And they are often what we consider common sense type things because it doesn't take a stretch of like, oh, I don't know. I don't know about this ruler thing. Yeah, it's all going to make sense when it's a postulate. So the points on a line can be matched 1-to-1 with real numbers. Now keep in mind, real numbers are not just integers. There's infinitely many real numbers at any point, right? Just like lines are made up of infinitely many points, there's infinitely many real numbers. So the real number that corresponds to a point, we actually just call that the coordinate of the point. And sometimes we'll put it on the coordinate plane. Sometimes we're just working on a number line, but we are going to have this idea that there's considered a coordinate, whether it be x1 or x2, there's going to be some kind of a value attached to that point. And then we also want to think about that the distance between those 2 points, this is a ruler, right? Which is written just as AB, no symbol on top, is the absolute value. And all that means is that it's always going to be positive. Distance is always positive, or the difference of the coordinates of the points A and B. So we're looking at the absolute value and just do the subtraction. One of the things that I'm going to just do a quick side note is some of you may be taking physics right now. And in physics, they don't just talk about distance, they do talk about position. And when we start talking about that, that's positive and negative when you're talking how much something has moved. So distance is always positive. Position can be left or right. It's directional. So we do want to have an understanding that for geometry, we are always talking distance. Okay. Segments that have equal length measures, so the same number. It doesn't have to be, they can be two different segments, right? But if that measurement is the same, then they are congruent segments. And do note that when we measure, we what I call read the white space. In other words, estimate one digit representing how close to the marking is your actual length. So that way, then when you round your estimate, it will equal that closest marking. This is important in science classes in particular because we do always want to estimate something so that we know how close our red measure, the number that we're reading, actually is to the actual length. And that extra digit just gives us some wiggle room when we do some calculations. And so we do want to always estimate, but the estimation is the number in the white space so that when we round it, it comes up to the marking that we think it is. So we'll do a quick little practice. I'm going to include that in this video. So we're going to estimate a B and CD to the nearest hundredth of a centimeter. I say hundredth because my markings are tenths. So you go one more decimal place beyond what your markings are. And if you're dealing with an inches inches are normally marked by powers of 2. So if it's marked in halves, you go to quarters. If it's marked quarters, you have to go to eighths. If it's marked in eighths, you have to go to sixteenths. And most inches are actually marked in sixteenths. That's the most common marking on a ruler for inches. You're going to have to go to 30 seconds. So not as much fun to do that. So I'm going to definitely recommend when you measure that you use centimeters because it's much easier to estimate our tenths. We're used to doing that. So with A and B, we can see that A is at 0 and B is approximately, I'm going to say it's 2.82. I do know I want it to round to 2.8, and it seems to me that maybe it's a little bit longer. My ruler is not right up against my lines because it's just, that's the way it's kind of drawn. So you just have to kind of do your best guess, or you can draw some additional lines to help you out. Kind of have to work it that way. When we look at CD, segment CD, the first thing we want to note is that C is actually above the number 1. So its coordinate is 1. D is somewhere there between 5 and 6. We're going to have to estimate where D is. I'm going to go ahead and say C is exactly at 1. Even though I really should have estimated that one, I'm going to say it was at 1. And so I am going to have to then subtract. And it struck me that it was maybe a little bit beyond the 7 mark, the 0.7 mark, but it wasn't quite to the 0.8, probably a little closer to the 7. But it was a little closer to halfway in between. So a little harder to estimate. But I did want it to make sure it rounded to the 7. So I did. But I had to subtract the 1 where my C started. So 4.74 centimeters. And finally, when 3 points lie on a line, you can say that one of them is between the other two. Now, I know this is on your notes, but I definitely would like you to understand that for this example, point B is the one that is between A and C. We can really say nothing else about A and C, but this idea of between, you're probably thinking, well, duh, Mrs. Krause, we know they're between, and that's fine. Now, some notes here. AB, nothing on top, represents the length of segment AB. Segment AB has got that little line, and it is the distance between points A and B. Really key concept is that segments are congruent, so we use our congruent symbol, whereas the lengths are equal, and we use equality. Lengths are equal because they're numbers. Segments are congruent because they are figures. So we have congruent figures and equal numbers.